Today I'm going to show you the difference of squares. Difference of squares is when you have a minus sign between two perfect squares. For example, x squared and 9. X squared is a perfect square because the square root of x squared is plain old x. The square root of 9 is 3. If I say x minus 3, x plus 3, I get the factored version of difference of squares. Difference of squares, if you were to multiply it back, you can have x times x, which is x squared. Then you would have x times 3, which is 3x. Then you would have negative 3 times x, which is negative 3x, and negative 3 times 3, which is negative 9. When we combine like terms, the middle terms end up becoming a 0x, which ultimately cancels out. This pattern occurs only with the minus sign, so we have to be real cautious not to have a sum of squares. I'm going to show you one more example. Let me just move this one. If I have 16x squared minus 25, again, I can take the square root of 16 and say 4x. The square root of 25 is 5. If I put another parenthesis with a minus in the other sign, that will create a situation where the two middle terms will cancel out when I am finished distributing, leaving us with 16x squared minus 25. If you see a problem like x to the 6th minus y to the 6th, a square root when the exponents are of such, even though 6 is not a perfect square, the square root of x to the 6th is in fact x to the 3rd. X to the 3rd times x to the 3rd would be x to the 6th because we add the exponents. So the same thing would occur with the y to the 6th. It would be y to the 3rd. And then we would have x to the 3rd plus y to the 3rd. Be very careful of the number 1. The number 1 can be tricky because if I have something like x to the 8th minus 1, 1 is actually a perfect square. If I find the square root of x to the 8th, square root of that would be x to the 4th plus 1, x to the 4th minus 1. The only problem and the reason I order caution is x to the 4th plus 1 is as far down as it can go. However, x to the 4th minus 1 can break into further problems of x squared plus 1, x squared minus 1, because 1 is still a perfect square, x to the 4th is still a perfect square, and there's a minus sign between it. This one gets even more interesting when we look and say, okay, x to the 4th plus 1 is okay, x squared plus 1 is okay, it's prime, but x squared minus 1 can go one more time as x plus 1, x minus 1. When they tell you to factor completely, you need to consider all factors until they are down to where they cannot be factored. So all of that began with x to the 8th minus 1, and it returned to us with 4 factors in the end.